variations: direct, inverse, and joint variations. The electrical resistance R ohms of a wire of a given length is inversely proportional to the square of the diameter of the wire, d millimeters. If R is equal to 2 ohms when d is equal to 3, find the value of R when d is equal to 4 millimeters. R is equal to 1.125 ohms. Three quantities P, Q, and R are such that P varies directly as the square of Q and inversely as the square of the square root of R. Given that P is equal to 20 when Q is equal to 5 and R is equal to 9, find P when Q is equal to 7 and R is equal to 25. If Q increases by 20% and R decreases by 36%, find the percentage increase in P. So part A, P is equal to 23.52, and part B, the percentage increase in P is 80%. The density of a solid spherical ball varies directly as its mass and inversely as the cube of its radius. When the mass of the ball is 500 grams and the radius is 5 centimeters, its density is 2 grams per cubic centimeter. Calculate the radius of the solid spherical ball of mass 540 grams and density of 10 grams per cubic centimeter. The radius is 3 centimeters. Three quantities T, X, and Y are such that T varies directly as X and inversely as the square root of Y. Find the percentage decrease in T if X decreases by 4% and Y increases by 44%. Now the percentage decrease is 20%. Given that y is inversely proportional to xn and k as the constant of proportionality, write down a formula connecting y, xn, and k. B. Using the value of n obtained in A above, find y when x is equal to 5 and a third. Now part A, the formula connecting y, x, n, and k is y is equal to k multiplied by 1 over x raised to the power of n. Part B, y is equal to 1.6875. Three variables P, Q, and R are such that P varies directly as Q and inversely as the square of R. When P is equal to 9, Q is equal to 12, and R is equal to 12. Find P when Q is equal to 15 and R is equal to 5. B. Express Q in terms of P and R. C. If P is increased by 20% and R is decreased by 10%, find 1. A simplified expression for the change in Q in terms of P and R. 2. The percentage change in Q. Now part A, you can clearly see that P is 1.8. Part B, the formula is P R squared all over K is equal to Q. And the last part, the percentage change is 2.7%. The Quantities P, Q, and R are such that P varies directly as Q and inversely as the square root of R. When P is equals to 8, Q is equals to 10, and R is equals to 16. Determine the equation connecting P, Q, R. The equation is P is equals to 3.2 multiplied by Q all over the square root of R. Three quantities P, Q, and R are such that P varies directly as Q and inversely as the square root of R. When P is equals to 8, Q is equals to 10, and R is equals to 16. Determine the equation connecting P, Q, and R. The equation is R is equals to ET multiplied by S all over T squared. Three quantities R, S, and T are such that R varies directly as S and inversely as the square of T. Given that R is equals to 480 when S is equals to 150 and T is equals to 5, write an equation connecting R, S, and T. B1, find the value of R when S is equals to 360 and T is equals to 1.5. B2, find the percentage change in R if S increases by 5% and T decreases by 20%. Part A, the equation is R is equals to 80 multiplied by S all over T squared. Part B, R is equals to 12,800. That's part B1. Part B2, the percentage change is 64.1%. Three quantities L, M, and N are such that L varies directly as M and inversely as S, the square of N. Given that L is equals to 2, when M is equals to 12 and N is equals to 6, determine the equation connecting the three quantities. The equation is L is equals to 6M all over N squared. Three quantities X, Y, and Z are such that X varies directly as the square root of Y and inversely as the fourth root of Z. When X is equals to 64, Y is equals to 16, and Z is equals to 625. Determine the equation connecting X, Y, and Z. B, find the value of Z when Y is equals to 36 and X is equals to 160. C, find the percentage change in X when Y is increased by 44%. But A, the equation connecting the two variables is X is equals to K into the square root of Y all over the fourth root of Z. But B, the value of Z when Y is 36 and X 160, the value of Z is 81. But C, the percentage increase is 20%. A variable P varies directly as T cubed and inversely as the square root of S. When T is equals to 2 and S is equals to 9, P is equals to 16. Determine the equation connecting P, T, and S. Hence, find P when S is equals to 36 and T is equals to 3. The equation connecting the two is P is equals to 6T cubed over the square root of S. The value of P when S is 36 and T is equals to 3, it is 27. A quantity P varies inversely as the square of another quantity L When P is equals to 0.025, L is equals to 4. Determine P when L is equals to 0.2. P is equals to 250. Two variables x and y are such that y varies directly as n raised to the power of n, where n is a constant. Given that y is equals to 320, when x is equals to 16 and y is equals to 2560, when x is equals to 64, find the value of n. The value of n is 1.5. Four quantities P, Q, R, and S are such that P varies directly at the square root of Q, and inversely at the square of the difference of R and S. Quantity Q is increased by 44%, while quantities R and S are each decreased by 10%. Find the corresponding percentage change in P correct to one decimal place. The percentage is 48.2%. The market value of a certain precious stone varies directly at the square of its mass. One such stone of mass 10 kg has a value of 600,000 shillings. Calculate the value of a similar stone whose mass is 18.5 kg. The value is 2,053,500 shillings. A quantity V varies directly as the square of U and inversely as the cube root of W. When U is 5 and W is 8, the values of V is equal to 375. Find the value of V when U is equal to 8 and W is equal to 125. V would be 384.